Okay, so our next topic is work, power, and efficiency. Work, we have a little formula for that. Work is force times distance. So if something is exerting a force and moving something a distance, we would say work was done. A little different than like I went to my job and I made some money, I did some work. Or even like I worked out really hard in the gym and I sweated a lot and I did work. Technically in science, something's got to move a distance after force is exerted on it to have done work. So this is also related to energy. Your units are going to be joules, J for joules. And if work is done on a system, energy is changing as well, so work and energy very much related. Note that we have a W here. We already had W for weight, so just be a little careful there. This W is work. But note, if there's no movement, there is no work. So I can say, I push on the board, really hard. I'm trying really hard. I'm exerting a lot of force. I'm pushing hard. But am I doing any work? Well, even though I might have a really big force, if I'm not moving anything a distance, then no, technically I'm not doing any work. So we have a couple problems. It says a lever is used to raise a 15 Newton rock. So note newtons, that's a unit of force. 2 meters above the ground. What was the work done by the lever? Okay, well, what was the force exerted by the lever? 15 newtons. What was the distance the object moved? 2 meters. We are in standard metric units, so that's fine. 30 joules of work was done by the lever. And note, of course, now that rock would have gained some potential energy, so work always relates to changing energy. Another question says a robber tries to pry open a safe. He uses 60 newtons of force on a crowbar, but the crowbar won't budge. How much work was done? Well, I do know the force number 60, sure. But if there was no distance, it doesn't matter how hard that guy is trying. If something doesn't move a distance, we don't say work was done. So that would be just 0 joules. All right, power is then a measure of how quickly you do work. So we've got work over time, not weight over time, but work over time. And your units here are watts. You may have heard that before, but now another W. So the unit is W for watts. This W is W for work, not to be confused with W for weight. But how quickly you can do something, how quickly that robber could pry open the safe, or how quickly that lever could lift up the rock, that's going to explain how powerful that thing is. You maybe are familiar with horsepower. 1 horsepower is about 746 watts. And that truly did come from the measure of a horse, like a horse pulling a cart way back in the day. And we still tie it into things today, like cars. A car requires 600,000 joules of work to accelerate for 12 seconds. How much power does the car have? Well, if you know the work, 600,000 joules of work, that's going to go on the top. Your time, seconds is standard metric units, so that'll go on the bottom. And you get about 50,000 watts. Now, just FYI, this just converted a second ago, was about 67 horsepower, which is way low for a NASCAR. They can be up to 750 horsepower. So this is really low.